welcome. I just noticed that our stream is not the right resolution. Okay, gonna live with that. I'm exciting. I am exciting. Oh, yes, I am. No. Sorry for that. I'm excited. I came up with something today and I worked on it already for some hours, and I'm really want to go through it and work on it actually today. So, yeah, hope you join me on this ride. And what am I talking about? So, lately I was trying more and more to lean like heavily into the AI side. So, like, basically put my work into the prompt machine. And therefore, actually be able to do complex stuff with it. And as always, there was a catch to it, and this catch was mostly like there's something I understand where it's coming from. It's not as easy to solve in the moment when you're in it, because it's like a slew of things that plays into it. And that's what I preach most of the time, is like you have to put in the work into your whole system, how you approach stuff to get it working properly. One thing that I noticed is that we with AI, we talk about chain of thought and reasoning and all this stuff, but I think we still tackle most of our problems in kind of a linear way, in a linear fashion. And I'd love to change that for myself, or maybe if it works for me, it works for others too. So that's why we will talk openly about this, like we do with most of our concepts. And let me actually change the title, because of course, I was so exciting. I prepared a new Xcuddy draw canvas for us. I'm really eager to dive into this because I was working on this. I had now to go through some other stuff and had to interrupt working on this, which got me not sad, but like sometimes you're so into something that you want to keep working on it, and that's basically where I was at today. Really excited. So let me quickly come up. No, it's not that. I have it here. Yes. By the way, I hope you can hear me properly. I'm actually sure you can see me, but which audio? Yeah. Okay, that's good. That's cool. We don't need audio today. I'm still thinking about how to get some music and some ambience into the streams, but for now, I'll hope to deliver like valuable content, so that the rest is not that important. Let me quickly, where is my stream title? Like, I'm really exciting to talk about this. Really excited. Like, that's what happens if like German tries to do like stuff in a foreign language, especially if it's English. I'm lucky that I don't have that hard of an accent like a lot of Germans do. But yeah. Let's see. I'll quickly check also if we are up on LinkedIn. I also get the chat onto this. Yes, so that looks good. Where we are, LinkedIn's showing that I am live, and this looks like, we're good. We're fine. Cool. Let's dive in, shall we? Unveiling the alpha. You've already seen it in the stream title, and let's talk about this a bit. And I think that will be mostly our focus today in today's stream. There we go. Let me just share all of my screen. Okay, cool. Unveiling the Alpha, a revolutionary AI framework for solving complex tasks. So what's that? Why are we solving complex tasks? Because I for one don't have anyone to do that for me, so I would love to have some help by AI. And for that matter, I thought, hey, let's think about how we could do this better, just based from all the experience. I have a fly in here, that's unfortunate. Based on all the experience that Jesus Christ, sorry. Based on all the experience we collected. I'll cut this out. Okay, so we have, let's imagine the following. We have some problem. I want to color it in blue. Like, let's call it task X. For example, let me get a bit smaller. Task X, for example, build me an app for managing my desk bookings. No, that's not cool. For managing my prompts. Let's just go with AI for managing my prompts. So I want an internal app. I want to build it myself. But I don't want to come up with all the things. So what we usually do, we take task X, and I use X here like on purpose. You'll see why in a bit. As we go ahead, and usually we have some like chain of thought approach to it, right? So like chain of thought, work through this step by step. And this kind of has a problem, because if we work through it step by step, then we go ahead and we have this one we have basically step one, create the framework, or choose to create the framework. Step two would be something like build. Build login. Step three, or maybe that's a wrong step two. Like, let's say create DB schema, and step three, build login. Yeah, I think you get the gist of it. And like step and like whatever, right? So and we go ahead to say, hey AI, please go and make this step by step. And then we go through all the steps and we create it. And I tried a lot. The problem is that in this situation, we go step by step and we have a lot of artifacts we create. We have some state, we could maybe have even like some, let's do this like this. We might even have some prompt state, which we communicate back and forth with. And like you can do all this, like, and you can even do like tree of thought where you get back and forth, like, but all of these approaches, at least from my experience, have one huge problem. And that is that we think we got task X. And if you think about how humans create stuff, it's not like that. When we create stuff, we start with an idea or something, and then we can And then we try to figure out an approach, like how to get a first step. Everyone's saying like, we might go for an MVP and stuff, but like if we do it like this and we give it a task, like if you, for example, use bolt.new. By the way, let's just see how this fares. So you go to bolt.new. It's an AI tool for building an app. And I will build me an app for managing my prompts with React and Supabase. So it's just like, okay, I have to sign in. Okay, so and then it goes ahead. It tries to figure out all the steps to take and starts building up the app. So it even shows you the code it generates. It has like a whole project template which it took. It builds everything up, and then you can even like see a preview. So, and this is cool, and it's also a good way to start off. But it comes with a lot of caveats, because as soon as you get even remotely more complex, stuff breaks and breaks and breaks even more if you go more complex, and you get to a point where you're basically looping, and you waste huge amounts of time just telling the AI what it had wrong, right? So how can we deal with that? And I was thinking hard about this, because like I always feel like I'm close to having basically everything programmed by AI, but I find myself again and again in a situation where we basically get stuck, and we waste more time than we save, because like I had like, it was just one line, but I wanted the AI to check the documentation and get stuff working. You know, like this is already like showing problems. You can send that like fix, and yeah, I don't want to make a bolt.new tutorial here, but you see like stuff breaks pretty quickly. Wait a second. I might even show some more on that. So bolt.new broke. Bolt.new already attempted everything from the get-go, like a prompt card, prompt form, the Supabase, the app, and everything. So it tried to go for the final product, like zero shot, and that's what I mean. Like even if we go for chain of thought and have a few shot problem a few shot approach to solving the problem, we still kind of have a zero shot mindset, because we have this initial idea, we build an initial plan, which is basically zero shot, and then we go and try to solve the steps below. And I think that's not how we work, and that's not how we build anything as humanity. Because like when we built the first car, we were not concerning ourselves about different climate zones in the first place. We were concerned about how to build an engine, and what if I can attach some wheels to it, right? And that's basically where we were at. And I think we should try to go for AI solutions the same way. And what do I mean by this? And this is all, I just have to disclaim this is all alpha, and I'm actually not, I'm actually still implementing this, but I'm implementing this already using this method where I already found out like it might actually work. But there's stuff to solve. And yeah, in today's stream, we will go through all of it. And I hope I can keep this interesting, because I have high hopes that this works. And if that works, I'll be happy. So what's the general idea? So I hope you all got where we're coming from, right? So it doesn't matter the way you try to solve for the task. You basically have a zero shot mentality in the first place, and that's a problem. Because maybe I should illustrate why that is a problem. All these things, they have their own details. And if you go for the whole thing at once, all these details have to match up. And the more details you have that have to match up, the sooner your application simply breaks. Or like will not work. Like the more parts have to work in harmony, basically, the harder it gets for the AI to get everything right, because it either has to be aware of everything, which means you blow up your context and you get bad outputs, or you're not aware of your context, but you in that way you can't rely on every single part just simply working, because you try to approach this whole solution at once, and that's what I try to get rid of. So what's the plan? So let's copy this one and say we have task X. So, and now we say that task X, we will not plan for the whole solution, but the first thing we will do with task X is let's make this green and empty. Well, let's make it green. So, is build up a derivation. I hope that's the wrong word. Derivation, yeah. So what do I mean by that? A derivation is basically try to abstract it down. And with that, it's kind of this first start with an MVP mentality, but I would love to apply this to level of complexity. And the question you have to ask here is, what is the core idea of the product? And what are the guiding principles? Jesus Christ. Principles. Yeah, that's right. What are the guiding principles? So you don't think about features and frameworks and whatnot. You go ahead and you think first about how to actually interpret the goal. What's the why behind it? It could say let's actually do this why. Yeah. So basically you have this why are we doing something, and starting from that, from the core idea and what are the guiding principles, is what could be the most simple version we can think of, where we say, okay, no, wait a second, where we say, okay, we have X, a derivation of X, which is basically most simple version of the core idea, right? So you go ahead and say, okay, that's the most simple version of the core idea. Here it might be just some what could we come up with for this example? Something without a UI, that's for sure, and something that just would be a healthy core, right? Because from that we try to build out X1 or X, that's the core. The important part for this, and we by the way, we're doing a live concept here, so yeah, please, if not everything's thought out to the max, yeah, yeah, that's just by design basically. But yeah, we have the core. This first step is already, we think already about this as a production ready version, right? It's not about being the ready version. It's not about being X. It's being a far, simple, really like core version of X. And one version where we can work on, we can get this ready, we can get this working, and we can derive a state from that. Means well, let's go with this. State was yellow. So we have a state, and I'll actually write this like in the corner here. This is our project state, and this state basically saves the information about what are we capable. What can we do now? What can we do now? And what are the current artifacts? I think that's the right spelling, right? So, what can we do now? What are the current artifacts? And this project state is what gets updated. The artifacts part is especially interesting. We'll get to this a bit later. But because we create the core, and the core already, like if we go from a software development problem, because that's like the first thing I want to tackle, because it like actually would improve my everyday work, or like take away work and I could do something else. So we'll stay with software development for the moment. So now we take this derivation X, we derive the current state from that. And by the way, that's all done with AI agents. So this is like an AI agent native framework, because we have different instances, different personas with different responsibilities that apply here. Quickly make some room here. Yeah. Okay. So we now have the first derivation. Now we go ahead and we have one agent that is responsible of knowing the core principles, or the guiding principles, and the core idea. Also knowing X, like which is basically the goal we want to go up to, without having the need to be exactly that goal. But we come to this later, or basically in a second. But we go ahead and said, okay, now we have core, and this is working. Now let's build the next layer of that, which would mean that we go ahead and we say, can I get this behind? Yeah, I can. Okay. So now we get ahead. Let's also make it green. And we can build up the next version of this, which will be the second derivation, which will be the first derivation, but just we add one layer of complexity. Like we say X, second derivation of X, which amounts to, let's just say core plus one level of complexity. Yeah, this is beautiful. Wait a second. Can we maybe get this working like this? No. Okay, you get this. But okay, now we have like X, which is core plus one level of complexity added, which would mean then we go ahead and make like, okay, we might have we might now have a database layer where we say, okay, we have our library data structure defined, and we could with like executing a console command, we could just add data to it, or executing SQL, like being just raw, but we have some like basis of the application, and we know that it's working. So we just take the working artifacts that we have, and we start basically new with the next layer, and we don't have to concern ourselves with the previous layers, because we only have to concern ourselves with the current layer we're working on. And by the way, all the agents that are working on this, they don't even know about the task X. They only know the guiding principles, and to not go completely in the wrong direction, because that's one of the challenges in this concept, is to steer the application to not like go completely off board. Like we want something to handle prompt applications, and it's building out a social media network. That wouldn't be desirable. So that's why we have to have some guiding principles, so that everyone knows the core idea, or everyone has basically the overarching guide to follow, and so everyone can stay in the lane, but inside the lane he can move. And that's the important part, because one thing that comes up then is, now we have defined the second derivation, which is basically an incremental improvement on the first one. That means now that we are able to see, okay, this is the current, like this is the idea for the new derivation, and that's only one agent that's aware of the create, or like one or two agents, maybe three. I'll still have to implement this completely. But basically, you have a creative team, which then decides on is the current derivation we defined now, and the layer we want to add, is that like coherent with our overarching guidelines and the final outcome we desire? Is that like on the path to that outcome? And there's one small thing, like if it's not, that might not be actually, or if it's not completely, or if there's some weirdness in it, that might be good, right? But think about everything you've built in your life. You actually are oftentimes there, like you have an idea, you start working on it, you get the first results, and then you think like, oh wait, that doesn't make any sense how I thought it would work in the first place, but it would make sense if it worked that way. So now you start like getting a bit away from your previous idea into something new, and that has to be okay. And that's basically that's, by the way, one of the harder parts of this whole concept, is to actually get into this area where you dial in your prompting and your agents in a way that they are able to make the right decisions. But I have one clue for that to support them, because you can set up the systems in their temperature and everything to actually be able to go to a point where you're able to give them some agency and some autonomy, but also give them the instructions that if they're not sure, they simply ask you. You're the human in the loop. You have the keys to the castle, basically. I think that's something we definitely need in this. But then you get to a point where you have an agent system working on stuff and just asking us for input if it's not sure. And now, then let's think about the previous streams we had. We want something where we can hands-free let work be done with us just giving input, with us being just the CEO of the project, and the rest is done by AI. And I think when we give the AI some freedom to work layer by layer and build upon each previous layer without having even to know what all the other layers before had done, because it just needs the current state and the guiding principles with the outcome to decide on the next layer, then we might have something that does not drown the AI in details, and that's basically the idea. So project state, let's also get the human in the loop here. Oh no, that's not what I wanted. Quickly, so yeah, that's what I wanted. So maybe I'll make this smaller, bring this to that. human in the loop, where basically we have every layer and the responsible agents are able to ask the human if there are any uncertainties. Or sometimes you have just two paths you can go, right? So you think about the next derivation or the next layer to add, and think, okay, it might be cool to add a UI element, or general like add a UI layer to this. But it could also be nice to first create the API, just like on the top of my head, right? And then it would be nice if you had the human, like the one who asked in the first place, just give some feedback. And yeah. And like I said, I already tried it, and I think I can also show you how I tried it to implement it like manually, like without programming anything. But we'll get to this later. So I talked a lot. I showed not that much. So let me introduce the next layer, which would be, let's just call this, I just call this X3, and then we make another one. Make it a bit bigger. Let's just say X. Boom, boom, boom. And then we most likely at some point will arrive at something that is not X, but is X adjacent. But the cool thing is, we had a lot of learnings along the way, which we iterated on. And even I think cooler thing is that we then get to a point where let's just quickly, sorry, call this X. And make it a bit bigger. We get to a point where we not only have X now, but we have X with a lot of thinking in between without polluting our state, because we have just some artifacts, the project state and the artifacts themselves. And we have the human in the loop who gives feedback. But from there, we build up the whole idea, the whole prompting, and we end up with our solution or something that's at least similar, but fulfills the general idea even better. And that's what I'm aiming for, because that makes actual use of the like autonomous part, or like of the intelligent part of artificial intelligence, is to have it be able to make decisions, right? There's one interesting topic if you like. I went ahead. I had this on the top of my head, and I was thinking about this for a long time now. And you have different obstacles to overcome. So just to recap, we have a task X. We build like a derivation of it, which means we extract the core idea, we extract the guiding principles, and then we go ahead and layer by layer build up the application up until we reach X or something X adjacent. Along the way, we always keep a project state. I forgot. We also will have documentation. Yeah. And this will be updated on each iteration. And that's basically the truth we're working with. And the human in the loop is, of course, always there. And then for the artifacts, that's actually kind of interesting, because if we think about the artifacts, let's keep it yellow. Let's make it like this. I came up with the idea because like you build up a project gets more complex, and you have to have some kind of compilation of all you've done. That means that you go ahead and you say, hey, I have not the artifacts as a whole in my context, like all the programming files, for example, all the configs and all the Python files, JavaScript files, whatever. But I create an artifacts graph along the way, which means that we go ahead and say, hey, I have these artifacts graph, which basically consists of nodes of artifacts with names and description. And second will be then we have nodes of artifacts with names and descriptions, and then we have the relationship. That's why I went for a graph and not only like for a file tree or something, but the relationship in between these artifacts. So, and that allows us to keep the context kind of compiled, or like keep it in limited length, basically, and to not pollute, but still keep the information needed. And then you could set up your agents, basically, who are executing on the next iteration. You could set them up to then look at the tree and just figure out which files are important, and then they take these files which are important, which they know because they had the ability to look at the graph, and they take these files and then go work on them. And that, imagine, like, that's also what you do. You build up a project, and this project has files, and you know the roughly the structure, you know in which file which function goes. You also there are books written about how to structure your project and where to put your files and stuff like that. And it's not only programming, it's the same basically for every more complex task you have. You have these underlying, basically hidden concepts that you apply just because you know it. That's like your professional habits, basically, you developed over the years working on on your everyday stuff, which allow you to go and went beyond all the I'm lost for words. So yeah, but I think you get the gist of it. I want to say that if you solve tasks as a human, and then you go ahead and want AI to solve this, we don't have to assume that we can just skip out on all this subconscious stuff that we just know because we did it, because we learned it, because we know it by heart, and expect AI to just be able to replicate this. It's not going to happen. And that's why I'm always, or I thought a lot over the last 2 years, especially, about what would context mean, what would common sense mean. And then these language models came ahead, and we had all of a sudden we had natural language understanding in algorithmic form. And I'm still to this date, I'm blown away by what it can do. Imagine you can speak by voice, and it processes the audio, understands the waves that are in there, which is in and of itself a huge task, and gets back to you with waves of its own. That's huge. It's really, really. I even can't. It's as close to a miracle as you can get, right? And that's where I think we have a lot of potential to improve when we give the AI more of our own thinking, of all our own intuition, and our own iteration process, and like build systems that kind of copy that, because then we get into some territory where it actually gets more consistent and more useful. This system, I promise you, it will break a lot. That's why I also called it alpha. It's kind of a wordplay there, but it's a first thought. I literally came up with the actual concept today. The idea is like also like not as old, but yeah, I thought a lot about like how we solve problems. Looked at startups, looked at like historical achievements that we had as a humanity, and actually kind of got me here. And I was kind of exciting when I started to prompt it, that it actually worked. I would love to talk about some of the challenges that we have. Let me quickly bring this up. That's the actual concept. Where do I save the challenges? That's not that. Okay. Just a second, I'll come up back. Okay. Because we have at least we have defined basically several obstacles, right? So quickly come up with that. We say this, that. So let me quickly go over it. So I can close the terminal here. So now we have following situation basically. We have our first task is define the simplest possible variant, right? And that I'm sorry, I know that's not pretty to look at, but for the moment, just stay with me, please. The obstacle is identifying a simplified version that accurately represents the core of X without oversimplifying, and the guiding principles should ensure consistency across iterations. So that's where we say, okay, we introduce an essence extraction agent that basically his only task is to extract this like guiding principles, so that then the derivation agent can go ahead and create the first derivation. Like the derivation agent operates based on the current state, desired outcome, and guiding principles, and it autonomously decides the next layer of complexity to add. Embracing a more explorative and adaptive approach means like you really have this notion of like, hey, this is where we want to go. This is what you have. Based on that, decide what you do next and keep it small, step by step also. But don't care about what was, just care about the current state. Look at it, we have it saved here. Please go ahead, make the next move. And that's how the application builds up properly. And if anyone's like, hey, basically this is chain of thought, like what are you talking about? I think it's not, but I'm also like, if someone has strong arguments for or against that, I'm open to hearing them. But I think, like I said, it's not especially the technique, it's more the way of thinking, because this is basically, I have a task and I assume I know all the steps to be taken, and then I go ahead and take them, which, it stays with X and just doesn't even, it just thinks about all the parts X could have and tries to build them out, and then it breaks. While here we go ahead and we don't take X literally, but we go ahead and we build up a derivation of X in the form of that we first, like, what's the general idea? What are the guiding principles? Then we take the simplest version that's kind of still working on in and of itself, start this as a core, and then we build layer upon layer upon layer until we got a final application, which consists of all the layers. And in each layer of itself, like each layer development has to be complete. So it's like if we allow to kind of like kind of like moving it around and being like cheating here and there, basically, it won't work. Each layer has to be complete in and of itself, and then we are able to get this iterative approach where we get like an idea, we abstract the idea, then we build small parts, and then we make them bigger and bigger and bigger until we have a solution. And this solution, like I said, it does not have to be X, exactly how we prompted it in the first place. It might be some X adjacent thing, which might be even better because it solves the initial goal better. One other cool thing, if you have these guiding principles, before you start, like it can extract the guiding principles, then you can basically adjust if it got the idea wrong before it even starts to implement anything. So you get in there, it gets the idea, you check the idea, because like I said, like human in the loop is quintessential for this concept. Because I don't want the AI to completely replace me, or I would, but like that's just not possible for the moment. That it just does all my stuff. But I want something that's at least to a degree autonomous, where I could say, okay, I put a box in my office and just let it run and think and ask and then go and run and iterate. Kind of can you say it's an agile approach where you define a common goal. The thing is, which got me also puzzled, like we try to assume that AI is able to like divide up a task into all its details and then work on it, and that we get a proper result. If we are honest, humans didn't get this right forever. That's why agile came in the first place, right? Because we identified, okay, maybe we need an iterative approach. The cool thing with AI is when you have this automated, you can make the steps as small as you want, because the time it takes to iterate through all of this is still a lot faster than whole development teams would be, right? So yeah, I think there is a lot to improve, and like I said, this is also like just a first concept, the first idea that I just wanted to discuss on stream, because it's basically it matches what I want to achieve with these streams, is to just hand over some ideas, some thinking processes that I just take with me every day, because I use these tools heavily every day and try and like spend basically all my free time on doing this and figuring out, because it's like I also think I have some responsibilities for my customers, which I consult on AI, to just be on top of the game and to be actually well informed, and also be able to create my own thoughts to this. And for you guys, of course, I'd like to deliver as much value as I can. So yeah, that's a quick overview on my idea of a layered approach where the final outcome does not have to match X, but we can actually, along the process, have the AI recognize a better path, ask us about this if we think it's a better path too, and then it runs ahead and says, okay, then we build the next layer based upon this like updated primitives and the updated state, and also save in the state, for example, why we chose the way, or why we chose to like kind of go a bit of a different route, still go reaching for the same goal. And to be honest, there's still a lot we have to overcome here before this works, if it ever will really properly, really good work. But as this is like more closely to how we humans solve problems, I kind of confident that this might even if it's not like completely having everything, it's at least something that's going to improve on the results with agentic frameworks. And I see it like it's a two-way opportunity. Like on the one hand, if you can layer up and layer up and layer, build up stuff and not pollute your context and therefore get better results, you can either do more complex stuff, or on the other hand, do the same stuff that works already with big models, but do it with smaller models and save money. So it's a win either way. Does this take up more tokens? Most certainly it will. But if I think about how much time and tokens I spend on iterating and reiterating and restarting sometimes on more complex development problems, like it's worth it. It's 100% worth it. So yeah. Let's go through some other potential obstacles we have, like ensuring consistency. Like I said, we do this with the guiding principles, which is basically the only thing that the executing agents know about the whole concept. Then we have, and we don't have a roadmap, because the roadmap would be again like the final approach, right? But we have just the AI decide layer upon layer what to add next, which would make sense in context of the current goal. But I don't have to know what has happened in all the layers before. Just need to know. I just need to know what to do next, and stay in the lane by guiding principles. Managing context length limitations. That's where the artifacts graph comes in. So if we have a lot of artifacts, we cannot put them all in the context because just would exceed any context over time. And therefore, on each iteration, we try to compile and update an artifacts graph, which, like I said, has nodes which describes the artifacts and has relationships in between them. So you have a source of truth where you can find out which artifacts for the current iteration might be interesting. Then we have coordination between agents. Therefore, we will have an orchestration agent, which is not the same agent as the derivation agent and the extraction agent, because I want to try to keep every agent focused on his tasks. That's why I also have like a creative team, because if something in the iterations went wrong, and consistently is not able to produce good results up to iteration like 5 or 6, then I can go ahead and just work on the creative part, because the rest is only executing, right? That's where the coordination between agents is done through an orchestration agent, or if you look at the Swarms library of OpenAI, they call it triage agent, but something in that ballpark. And also the orchestration agent, I think that's something for the future. What could be done is that we go ahead, we take the orchestration agent and let it decide on tasks which are blocking, which need to be done sequentially, or tasks that are basically self-contained and can be done in parallel, which could improve the overall iteration speed. Then we will have some testing agents that basically do functional testing, execute code. That's why I think this all has to happen in a sandbox. But that's actually really important that we have someone that just tests if the code works as expected, maybe comes up with automated testing. That's something we have to keep to make sure. Then also, if you implement this, maybe you try it yourself something. Think about constraining the resources, especially if you're using an API. If you have like a Mac Studio where this thing just iterating by itself and you don't care because you only have like electricity from your solar system that's wasted anyway, or it's like just going back to the central electricity hub, then yeah, just go ahead. You might leave it unconstrained, at least in terms of iteration. You have still to have guardrails for what code it can produce and what not. And create limits for the iteration. Create for the first try to implement this, I added a token limit, which I said, okay, like the whole thing is not allowed to exceed X amount of tokens. I think then you should be fine. Like before you run it with an API, make sure this works, because it might be pretty expensive for any agent approach. By the way, it's not like this framework. Like any agent stuff you build, try to keep it clean. And the last thing, that's nothing pretty important. But yeah, there you have it. Kept it under an hour. I would now go just in some of the prompting, which I did to try this out. It's got kind of meta because I prompted Claude to build a sample of this, which we can then open source by already implementing this method. So building the framework by using the framework. But yeah, let me quickly bring this up. And yeah, so we have basically two parts, because I first naively, to be honest, started with just like, hey, this is our framework. Like this is the framework definition, by the way. Which agents are needed, like basically the whole idea in writing. And like I said, I came up with this new concept for solving complex tasks with AI. I would love for us to simulate the principles, the core concepts of that for solving the implementation of the framework. It's a bit meta, but I hope you get what I mean. Of course, Claude got it. It said, I understand that you want to use this framework to implement itself and to demonstrate its principles. And then it's directly switched into the role of the different agents and created basically the essence extraction, created the initial version, like the first derivation, and also defined next steps, which I'm not sure if I like that one, but we'll see. And also creates like the first graph node with Mermaid, which is an open source graph. Mermaid graph and charting tool, basically. And then that was really nice, and that's how I actually expect it to work. It asks questions like, do you agree with the extracted core values? Is the proposed simplified version of derivation of X maintaining essential aspects while being minimal enough for first iteration? And would you like to adjust any aspects of this initial setup before we proceed with the implementation? And I was like, yeah, agree. No, let's start with that. Just because like I was excited. I wanted to keep going, and I also thought, what he came up with was actually a good first version. So let's and we went ahead and he just did the second iteration. Like this is like where we said, okay, like this is the implementation of that. Oh, was it still the first iteration? Yeah. Now I'm with you. So then I said, okay, let's execute on that. Like you had the first derivation. Let's implement x1 basically, or first derivation of x. And we went ahead. We implemented the first derivation of that. And then I was noticing, hey, like this is all like there is no AI in there. This is like all all the stuff's mocked, and so like I was like, that's not what I meant, by the way. And then I thought, okay, of course, I knew that I want to have something that's production ready at every level, basically. But AI doesn't know that, and it's also not in the concept, by the way. It's something that I learned by actually applying this, and I started like, okay, let's restart this iteration, and add the following principle: each iteration has to assume that it's a production-ready version of the software. That means we try to avoid mocking API, but if we create agents, we use AI agents with an actual model. The orchestration agent can ask for the API to use. In this case, please use the Claude API with the model Claude Sonnet 3.5, which was released like last week or week before something. And then it went ahead and like rebuilt this. But before it did that, it actually asks me to give some feedback. And that's something I really enjoy, because that's actually what I want. I want the human in the loop. I want the AI to actually ask questions if stuff is ambiguous, right? Because ambiguity is what value of ambiguity, we had this in another content piece, is where stuff breaks. Because we mean one thing, AI understands another thing, we screwed, basically. So, okay. And then I gave it the answers. It created the first iteration. Then I copied it over, which is still manually, because I was the testing agent, basically. Copied it over. It had some errors and stuff, and wasn't working because like of minor issues. I changed stuff up, and then it worked, and it was fine. And I then posted the updated code, which was different from that one, and it changed. It recognized the changes, and then wanted just to ask what to do next. And I said like, okay, please go on with the next iteration. Then it created the next iteration. It added additional agents, and we got this copied over again. We've seen, okay, this the testing failed. I put in what was missing. It just, yeah. It is something that an implementation agent would do. Like, it would come up with the solution. It would then, or like the derivation would give the basic concept. Then the implementation agent would implement it, find that there are errors, and just like keep iterating on this until it's done. Then it goes ahead and said, "Hey, here's the we updated the state. You can go on and to the next iteration." And that's what we did. And at that point, I noticed, okay, I need some more stuff. I need some documentation, because I want some different frameworks to be used, and not only like plain Claude SDK. And there, I thought, okay, let's use the projects of Claude, and I just said, okay, I want to transfer this to another chat. Please just give me a current state. And that's what it did. It just gave me the current state, and I copied that state. And let's switch quickly to the projects. And then I used it, and the way I did it was like, okay, I first created some documents and added them, and also added the main file, like the main Python file. So the Iterative Derivation Agent Framework, which I posted into the chat before, is now part of the project database. The same goes for the Python file, which has to be renewed every time, like after every iteration. And I also updated the system prompt to be aware of all of that. And then I went ahead and said, hey, this is basically our current stage. And I, for now, just wanted to do a refactor. And that's what we did. We refactored it, used the L framework for prompting, because it allows us to have a history about on our prompt. And we also had some, and we also added OpenAI swarms for the agent handling. Why did I do this? Like I told you all in this last stream or the stream before, the Swarms library is pretty cool because it abstracts away a lot of the technical stuff, so you can focus on the prompting, and that's the same with L, which just basically the same. So I want the code to look as much as our prompting system, basically, without a lot of distraction and boilerplate in between. So yeah, that's where we came from. That's where we were at with all of that. Now, yeah, and that's basically where we stopped, and I had to do other things. But now, what I actually try to achieve here is after refactoring, I would then delete the main, upload the new main, and then say for every iteration, I would start a new chat. So say, okay, this is the current state. I most likely would, for this one, take the same state, just exchange the main Python file with the new one, and then go ahead and say, okay, let's go with the next iteration. And that's how we iterate through that manually. And I want to also have some implementation for that. But yeah, that one I first have to finish, and then I'll release it to all of you to test it yourself. But yeah, that's that's the new framework I came up with. I'm really curious if anyone knows anyone to actually has something similar seen. Maybe I'm not aware of all the papers and everything, but yeah, you might have some opinions on that. Just a quick recap, and then I think we'll ready for today. I have the problem that I work with a lot of complex, or I tried to work with AI on more complex solutions, and I got stuck again and again. And I'm pretty sure everyone that tried this, kind of had the same issues, or might have had the same issues. I just see Vraj. I hope I spell your name right. Hey, hello. Thanks for joining in. So yeah, basically recapping this. I had tasks, and I have a task X, and what we used to do is, and also what's O1 basically is trained for, is building out this chain of thought, coming up with all the details. And it's not about chain of thought in general. It's more of we still have this zero-shot mindset, even if we apply few-shot strategies. And that's where we blow up our state, where we put in a bunch of details which have to work in harmony for stuff to not break. And if stuff breaks, it oftentimes breaks in a way that if you fix that, the next thing breaks, and then you iterate and go, and you lose a bunch of time which you saved in the first place. And oftentimes I find myself in a space where I barely saved any time. Not always, of course, but sometimes it's like that. And sometimes it's even costing a lot more to guide the AI and to come up with some rules and files and prompts to a degree where I would have been faster if I just would have done it myself. So, and how I approach this, or how I want to solve this now, is by just taking a new principle where I just take the task, and instead of taking the task at hand, we try to find out what's the core idea, what are the guiding principles of that, why are we doing this, and then we come up with a core, which is the most simple version of the core idea that we can imagine, and then we start building layer by layer, and each layer in and of itself has to be done, has to be ready, kind of production ready if you want. So that we go ahead then and say, okay, each layer while building is self-contained. We get the current state, what can we do now? What's the current capabilities of our solution? What are the current artifacts? For that, we create an artifacts graph where every node of that graph is basically what artifact it is and what's the artifact and what's its function. And when we go ahead and also add relationships in between these artifacts so that we know how they intertwine, which helps us then on each layer to efficiently generate or efficiently grab all the artifacts that we need to iterate on that. So, and then we also have the human in the loop here, where we say, okay, on each layer, we have a creative team of agents which is working on like adding the next layer of complexity. And by doing that, or while adding the next layer of complexity, if there's any uncertainty on how to go on, or if there are several paths, we ask the human in the loop for just providing feedback, and then we go on. And the cool thing about this is like every layer is like it's closed, it's done, and we don't have to look at what has been done in detail, or like what was the steps and what were the iterations and stuff. We don't need all of that. We just need a creative team that needs basically what's the current state, what are the guiding principles, and how does everything align with the goal that we have. And that might lead to something where X is not actually the X we started with, but something X adjacent, which basically is something different than what we started with, but it solves the problem even better that we had, or that we wanted to solve. And that's the cool thing of it, like, because that's how we work as humans, is that we go step by step, layer by layer, and build up something to actually come to a solution. And I really hope that we can use this framework. By the way, I named it the ID agent framework, with ID standing for iterative derivations. But yeah, this iterative derivation framework was kind of a rough name. Therefore, I came up with the ID agent framework. So I hope you liked it, and will I definitely will have a follow-up stream maybe next week to just see what we can we can do on top of it. And that being said, thank you for listening. I hope you have a great day, evening, or whatever time and time zone you're in. And hope you join me next week. Next week we might do. I don't think we will do Friday, but we might do a Saturday stream next week. But I'll come back to you on that. Until then, we might do a dev stream on Sunday. If you want some more hands-on action and coding, join me there. And until then, see you the next.